So hi everyone, so my name is Renaud Lambiotte. I'm professor of mathematics at the University of Namur, Belgium. And I'm also head of the Namur Center for Complex Systems. And I'm going to try to give you a short and still broad overview of the type of research that we do. So I'm here to present my university, but also a research program that we are running in conjunction with the University of Louvain, which is dedicated to the theoretical questions associated to the mining and optimization of big data. And that's something that which is under the supervision of François Glinard. So we are interested in data, as most of you, I suppose, but we are mainly interested in data because they raise computational and theoretical challenges. So it means that all of these data that you're interested in, well, they raise some interesting questions for us in order to build new tools and new models to help you analyze them. And obviously, well, big data are big, for sure, but they're also interesting because they tend to have a multiple nature. They are relational, they also tend to be temporal, so it means that you also need to do some time series analysis, and they also have a lot of geometrical constraints. So in our work, what we are really trying to do is to try to exploit some structures in order to improve algorithms. And so we try to exploit structures that are present in the data, but also mathematical structures, so mathematical structures that are present into the models. And well, this is certainly something that we do in general, but we are mainly interested, one thing we are interested in our programs related to clustering. So clustering, as you know, is a very classical problem in data mining, which can be used for networks, but also when you are looking at points in certain space. And well, I was lucky enough to be involved in this Louvain algorithm that has been described a few times, which is a clustering algorithm to find clusters in networks. And that really works well because it exploits the existence of structures at different scales in the system. And that's something which has now been implemented in quite a few solutions for network analysis, which has been used when people analyze social media, but also neuroimaging, as you saw in the last slide. So I think that for the problem of clustering networks, that's something which is quite understood nowadays, but there are still quite a few challenges that you are interested in. The first one would be problems related to block modeling. So how do you find sets of nodes that are maybe not well connected with each other, but which play the same kind of role? So another problem which is also quite crucial is the problem of visualization. So how do you visualize the outcome of these algorithms? It's very nice to be able to produce clusters, but how do you make them readable for the end user? And then a last point, which is something that we've been working hard for the last years, is trying to incorporate the dynamics into the algorithms and try to really to build algorithms to find dynamical clusters and dynamical communities in networks. So I think that's a point which is quite important also to keep in mind is that, well, when people play with data, well, one always has to find the right model in order to format the data and to put them into algorithms. So it means that usually we have a database and we need to find the right way, the right variables to look at and the right to throw away. And one way, for instance, to look at CDR data, that would be something that comes from mobile phone studies, would be to focus on the relations between the individuals, in which case you will look at the social network and you will be interested in the structure of that social network. But by doing so, you will throw away all sorts of temporal information, which can be useful, and it's known that these social networks tend to have quite interesting temporal patterns, burstiness, correlations, non-stationary patterns. And also something else which is thrown away when people use networks is the existence of real pathways inside the system. And one thing that we are quite interested in is to try to incorporate temporal information and pathway information into the construction of algorithms. So to finish, so we are interested in theoretical questions, but also at times at more practical ones. And we've been working for a few years now with people at Cambridge, but also with the people at Foursquare. And we have been interested, for instance, in trying to predict transitions between different places in a city. And well, here I think it's one case when we have a fairly simple algorithm which is based on the structures that are present in the system, which is going to be presented at WWW, and which kind of outperforms supervised methods. So another type of application that we do, we've been working with people to analyze data from Uber and the yellow cabs in New York City. And actually what we've been doing is not only to try to compare the price for a certain ride, but also because we observe some patterns, we've been constructing a solution for users, so an iOS and Android application that the people can use, entering the final destination, and we tell them what's the best choice for them in order to pay less. So that's my last slide. So I would also like to invite you to contact me. I'm leaving just after that because I'm heading to Japan. So just send me an email. And otherwise, we are organizing a conference in October on data visualization at the Mundanum, and you're very welcome. Thank you.